Hey guys, welcome back. So today I brought home this Briggs and Stratton generator, or at least it used to be. Someone already replaced the original 10-horse Briggs engine with this Subaru EX30. The description on this listing stated that this runs, makes power, but under no load, the engine idles too high. Basically, it's over revving. And when I went to pick it up, the seller tried to start it. After about 30 pulls, we got nothing except fuel dripping out of the carburetor. So he was asking $125 for it. I offered him $100 and he took me up on it. So here it is. Now, assuming I can get the engine running too fast issue sorted out, I can see there's a lot of other things that need to be dealt with on this machine. And just starting here on this side, the oil sensor is disconnected. Also, the Subaru engine is an inch higher where the crank comes out, and you can see the stator goes downhill a bit, about an inch. So that needs to be leveled out. And here on the engine side, I can see that the spring, the governor spring, which goes from here to here, is missing. And that's what holds the throttle open. It's not until the engine starts where the governor weights build up enough force to close the throttle. So why that spring's missing, I don't know. Also, the idle set screw looks to be a little bit too far out. It's kind of hard to tell. I'd say it's about halfway. And on generators, they don't idle. So that could be an issue. I guess I don't know kind of what came first here. Did the governor break internally, like the weights broke off and the engine was just screaming out of control, so they removed the spring and then just set the speed with the idle screw, which is not correct. You're not gonna get, the engine's not gonna maintain itself. Or was the spring lost, the engine was idling really slow, and then they bumped it up with the screw. I don't know, it's kind of the chicken or the egg here, but we'll find out. And lastly, the carburetor. This looks like a clone. You know, I can tell by looking at this bowl. This is usually a bolt that you use a socket on for the OEM Mikuni. In this case, it's just a screw, probably a JIS. And I've tried clones before, they don't run too well. Luckily, he did include what appears to be the OEM Mikuni carb that he pulled off of it. So both of these will need to be cleaned up, and hopefully I can stick with this one, but we will have a couple options. Also, the breather line is disconnected, but at least it's here. We are missing a clip on the air box, and it's really hard to show you, but there is no heat shielding at all between the exhaust and the stator, in the exhaust and the plastic fuel tank. That was omitted altogether. And you can tell just by looking at it, this was stored outdoors, so most likely we have water in the gas, potentially water in the block. With the flooding carb, we could also have fuel in the block, and with the engine over revving and the governor potentially broken, we might have bits of metal inside that block as well. So I'm just gonna start off changing the oil and see what we're dealing with. I guess we'll check the oil first before letting it out. Yeah, and there is oil. It's kind of in between full and add, so that's a good start. Yeah, overall, not too bad. There's no water in that oil, no fuel. Not seeing any shiny bits or any chunks of metal. So most likely the governor did not blow up. I'd say the engine actually is pretty healthy. So I just put some fresh oil in there, and I think I'm gonna get the gas out of the tank. Again, this was stored outdoors. I have no idea the condition of this fuel, and there's a lot of it in here. So we'll get that out and actually probably just take the tank off. It'll be a lot easier to work on this thing. That is mostly water that came out of there. I don't even smell fuel. You can tell by the surface tension. That is water. That is 99% water. There might be a very thin layer of gas sitting on top. So yeah, the carb's probably in pretty bad shape. I imagine it's quite rusted, and there's probably a lot more water where that came from. So I haven't had a chance to use this yet. This is called Mr. Funnel. It is a fuel filter, but the cool thing that it does is it separates the water from the gas. So you can pour in water and gas, and only gas or fuel will come out. The water will stay behind. At least that's what it claims. So I'll put it to the test. This bottle, what's in here, came from this tank, which went through Mr. Funnel. Yeah, didn't do a very good job. Anyway, this is how I usually separate water from fuel. I pour it into a clear bottle, let it settle out, pour the top off into a tank to use, and then the water goes into a separate bottle to recycle. What do you think that is? Okay, well, this is what's left of the original cap. The cap that came on this had a gauge to indicate the fuel level, and this was the float. And as it goes up and down, it would turn the gauge. Obviously, that is long gone, except for the original bits that broke off. Yeah, there's no air filter. That's almost as bad as running without oil. That can kill an engine pretty fast. Huh. You haven't seen that one before. Looks like it's double nutted on the stud on both sides. So, yeah, I don't think that's factory. Maybe it's just acting as a spacer. Potentially the stud is stripped out. Yeah, so that bolt, there was actually 2 bolts on each side. They were just acting as a spacer. And I think it's because the back here is a little bit egged out. Not too bad. Probably could have just used a washer, but a bolt works fine. Also, this here was supposed to be secured to this bracket, which it wasn't. Also, the other side was attached to nothing. It should have been attached to the engine mount up in here, and that is missing a bolt. So the engine's not secured on this side. We'll definitely have to fix that before trying this thing out. Yeah, something's not right here. The way this works on the Subarus is usually you can slide this out about halfway to clear this, and then you can lift this connection out. And it's not budging. I mean, this is tight. The governor can go that way, but there's no give coming this way. And now that I'm looking at the rod closer, it almost looks homemade. Like someone took a wire hanger and kind of shaped it and put it in place. But yeah, it's definitely not the right length. It was a good try though. Okay, let's see what these guys look like inside. Yeah, the clone looks pretty decent. So the seller said it was running a few months ago. And given what I see in there, I tend to believe him. Now this is the one he replaced with that, because this one had an issue. And I can just tell by the dust that fell out, yeah, there probably is an issue. Wow. Yeah, this one's pretty bad. I was hoping to save it. And I mean, I could clean it up and get it to run again, but I don't think it's ever going to run right. It's just too far gone. So yeah, this one, I think this one's out. The clone actually looks fine. So I'm just gonna go through all the holes here with a wire, make sure there's no obstructions. You know, we'll test the function of the needle and seat. And I think I'm just gonna throw this one back together. I'm sure the issue with it was just that it was full of water. Yeah, needle and seat work fine. Couldn't find any obstructions here, so I think this carb is fine as is. So I'll just throw the bowl back on and try to figure out what to do about that governor arm, governor spring situation. So I do have several EX30 engines currently with the correct OEM governor connecting rod here. I did measure one. It came in at 8¼ inches. And I double checked the measurement on this, and we're just about there. It's maybe a 1/16 shy. So even though this is homemade, it should work. But more concerningly, when checking out the throttle here, this is idle and this is full throttle. So the governor linkage should just make it to right here, maybe a touch past. That's it. This one, you can keep going quite a bit further. And that's a big problem, because inside here, if you follow the shaft into the engine, there is a plate that is touching the governor. And when the weight starts spinning, it pushes that plate to slow the engine down. And the entire movement of that is about 1/4 of an inch, maybe 1/3 of an inch. So in this position, it should be touching that plate. In this position, it will not be. And most likely the governor will not be able to reach the plate at all. So this here needs to be adjusted. So it might be a little easier to show you on this blown up Briggs. The governor is actually adjusted properly. And right now I have the throttle in full open throttle, and the governor linkage here pretty much lines up with this. It doesn't go way past. And I can only go this way. I can't push it any further that way. So that's what needs to happen here. And I do have a Briggs governor removed, or at least the governor arm, the shaft, and the plate that goes inside the engine. So this is what I'm talking about when I say the plate. The governor should be making contact with this plate. And if you have it misadjusted, maybe 1/8 of a turn, that plate's going to be way too far away, and the governor's not going to be able to influence the position of the throttle. So if you're unsure the governor's working, you don't have to open up the engine or start it to find out. In this case, you just disconnect this rod right here and any springs. Someone already did that, so we have no spring and we're disconnected. You just want to bring the governor arm to the left or to the right. It really depends on your setup. This is idle, this is full throttle. So you want to move it in the direction of full throttle until it stops. And it kind of looks like it's hitting here, but it's not. This is actually the point where the plate is hitting the governor inside the engine. And if I pull the engine over right now and the governor is working, we should see this arm jump to the right, basically trying to close the throttle plate. And it did. So most likely the governor's fully intact inside that engine. I'm going to reconnect this linkage here and actually tighten the carb down temporarily and make the adjustment on the governor. Before you proceed, make sure you have your orientation. Figure out where idle is and full throttle. You want to hold basically the carburetor in full throttle and loosen this bolt. And once that's done, you have to rotate this shaft right here. You want to rotate it in the direction that the shaft moves when you're moving to full throttle. So in this case, the shaft moves clockwise when going to full throttle. So once this is loose, you just want to turn this clockwise until it stops. And once you reach that point, you just tighten that back up. Double check that it still moves, full open, full closed. If you did this backwards, this might be locked up. And now we can actually just remove this again. We'll do the same check. We'll open this to full throttle, go over as far as we can, and that's it. It now lines up. And you can see the arm itself, the position's very different. So that should do it. The governor should be able to slow this thing down now. So what I'm gonna do, I actually have a spring to connect these two. So I'm gonna reconnect the governor arm, this spring, and replace the missing spring back this way out. And I think we'll try to start it. This is the spring I have. It is from an EX30. I pulled it off because it was rusted, and when that happens, they lose a bit of their spring, making it difficult to get to 61.5 Hertz without maxing out this screw. With that said, I think it could actually still get it to 61.5 Hertz. Even so, I don't care. You know, I just want to have some sort of control over the throttle. And yeah, if this thing comes back and does what it should, I'll be getting a new governor arm, a new governor spring, and I'm sure a bunch of other things. Okay, ready to give this thing a try. I am pretty confident that the governor is going to function the way that it should now that it's been adjusted. And the carb, I have my doubts on. I have tried a Mikuni clone before, and it ran the engine too rich. So hopefully this one works. It does seem like a different clone, slightly. And I did put the Mikuni through the ultrasonic, and it came out looking like a fossil. So that is not going to be an option. Now, once it's running, I want to listen to it, make sure it sounds good. It was obviously over revving for some time. Hopefully it didn't damage the engine. And I did take a closer look at this governor arm on the Subaru that I have. And I actually take back what I said before. I think this rod here is the correct one. So once it's running, I'm gonna bump the speed up to 61.5 Hertz, assuming the engine sounds good. I'll probably also plug in the oil sensor, and then we'll load it up to 3,000 watts, make sure that the engine is healthy. No power, but it might be running too slow. The good news is the engine sounds good. It started second pull. Probably would have started the first if I'd had the ignition set to on. Anyway, the carb, it's running it rich, but at least it's running it. The spring doesn't have enough spring to bring this engine up to speed, even after turning this all the way in. So these things are going to need to be dealt with, but the governor is working. As soon as the engine started, it closed that throttle like it should. So that's all good news. Unfortunately, the power head's not working, and that was not supposed to be the issue with this. So I'm going to get this back inside, and we'll do some tests on the power head. I'm going to check the stator through the outlets, and there's two windings here, leg 1, leg 2. Briggs wires it like this. You have to check one on the top and one on the bottom, and if you're not sure, just check them all. They should be about the same value. And for this one, I know that it's a pretty low value. Usually it's around 0.3 ohms or 0.2. This meter has 0.1 resistance built in. And with this meter, I usually get around 0.3 ohms. Yeah, it's about 0.3. And the bottom one seems to be healthier. Let me just check the top over here. Yeah, and it's the same. So most likely the contacts are a little dirty here, but we got 0.2, 0.3 here, 0.2, 0.3 here. These are separate legs, so the readings are consistent. So I'm gonna pull the cover off the generator head and we'll test down there. Yeah, unfortunately, I think this stator is done. If you look in here, you can see there is a little bit of copper here, but most of it's very dark and not the correct color. And you can see the same thing over there too. This winding right there, the copper looks good, but then right next to it, it's all dark, very dark and charred. So yeah, the stator's done. I may have jumped the gun a bit declaring the stator dead. I was expecting it to look more like this. This is also from a Briggs and Stratton. The part number here is almost the exact same number. It only differs on the last digit by 1. But it doesn't make sense. If you look at the ropes and even the zip ties, they are not burnt at all. They're not broken. So there has not been a thermal meltdown. And to top it off, it's actually been a couple days since I declared this thing dead. And tonight I was watching the small engine mechanic. He was working on a 20,000 watt Cummins generator with a bad rotor. So he pulled the end cover off and the stator, the wires looked just like this. And he went on to say that, he doesn't know why, but sometimes manufacturers do use a black varnish. And given the fact that the stator tested well and the ropes aren't burnt or broken, that's what I'm starting to think that this is. It's just black varnish on those wires. So I'm going to proceed with testing the rest of the coils and do all the tests I can to finish checking the health of the stator. So I got the multimeter out again, set to ohms. Gonna check the DPE winding on this. Generally it is 1.5 ohms. We're at 1.4, so that looks good. And I've got the brushes off, so I'm going to test the slip rings. These usually come in at about 25 ohms. Okay, we're at 24.3. So the rotor seems to be good. Now we're going to check each winding to see if there's any failure in the insulation, meaning is this winding connected to one of the main windings? So I unplugged the stator from the outlets with the quick disconnect, and the way it's wired is leg 1, leg 2. So we just need to check each leg and make sure that stays as open lead. And it is. And then the last test is just test it to ground. And we get no reading. So DPE winding seems to be good. I'll just plug this into the main winding. Maybe. Then we do the same test. Check the other main winding. We're good. Check the DPE. No connection. We're good. And then check to ground. And we're good. So here's the last coil. I guess we've already kind of tested this, but no connection to DPE. No connection to the other coil. And no connection to ground. So, I mean, this tells me that the insulation is good. All the coils test well, the rotor tests well. There's no connections where they shouldn't be. So these are the brushes that were on this machine, and this is pretty basic. It's just the 2 brushes and a bridge rectifier on the top. Now, I was going to test each of the diodes to make sure they're working, and yeah, I discovered something. You may have already spotted it. But these diodes form a full bridge rectifier. You need 4 diodes to do that. I only see 3. There's one missing here, but you can see on the circuit board, it's supposed to be right here. So this here is another one from another generator, and you can see the missing diode. So without that diode, it's not going to do a full bridge. It's going to do a half bridge, and that is going to cause a big problem powering this up. So this is the smoking gun right here. It could be this. Well, it's definitely this. Hopefully there's not something else wrong. So I'm going to put this one on, and we'll give it another try. And when connecting the brushes, make sure the tab side goes in. The brushes are in DC, and it is polarity sensitive. These brushes do not need to be tight. These strip out extremely easily. And I've picked up a lot of generators where people have stripped them out. And when that happens, I mean, you could, I guess, put a bigger bolt in there. I find Teflon usually works. Yeah, and actually this bottom one is stripped out. So I'm gonna try some Teflon. And the idea is you're just making it thicker so the threads will grab a little bit better to what's left. Yeah, that's pretty good. And I believe red was on the top, but this is AC going in, so should be fine either way. Okay, you can see it's not too nice out. I just rolled it out of the garage. It's gonna do a quick test. Want to see if it makes power now. You know, I also cut this governor spring to give it more tension, so I should be able to get it up to speed. So let's see what happens. Nice. Well, that was odd. Just shut down. All right, I see the problem. The spring that I cut and stretched actually broke and flew off. So there's nothing holding the throttle open. It's just the governor pushing that throttle closed, which is why it just sputtered and died. So that's fine. I know we need a new spring anyway. I got what I needed out of it. The generator head works. So the next step here, I actually want to take this thing off the frame. The frame has to be fixed or just swapped altogether. Also the heat shield, to get that on, I actually have to uninstall the generator head to do it. So that's what I'm gonna do. We'll get the stator, the rotor, the bell housing off, get the engine out of the frame, and then go from there. This is the heat shield I want to use. It's from a Husky HU5000. You secure it in 3 spots, 2 here and 1 on the top. So the stator that's on here now, the Briggs stator, is about 1 inch larger in diameter, and that's blocking me from getting those bolts out. The only way to do it is to remove the power head and the bell housing. And there's other reasons too I want to get this off. I actually want to get the engine out of this frame, and the engine is a bit wider than the frame, so I don't think I'm going to be able to easily get it out without removing the power head. And the reason for that is I have a better frame. You know, this one is it's not too bad, but it is rusted pretty bad here and damaged, that bottom rail. Also, this is a Briggs branded frame with a red Subaru engine. I have a red Husky frame that's in excellent condition, and Huskies commonly come with Subarus, so I think it'll look a lot less out of place. So the plan is, you know, get the gen head off, get the engine off, paint up the exhaust, and put it all back together over there. Gonna use a gear puller to pull this off. This housing here should separate. Sometimes you don't need it, but normally you do. Just go easy on it. This cracks very easily. And with any luck, the last guy left some threads for me. I'm gonna try to get the bolt out now. I did already try an impact, it didn't budge. I think it is over torqued. So I filled the cylinder with rope and just gonna crank down on it. Hopefully it'll break free. The last guy put some threads in there, so hopefully it's an M12 1.75. So an M12 1.75 does not fit on those threads. I finally did figure out that it is a 7/16 14 TPI, which is a pretty close match. I think there's a little bit less thread engagement, so it could potentially strip out, but we'll give it a try, see how it works out. That is tight. Yeah, that was one of the dirtier engines I've had to clean. It's looking a lot better now. A lot of gunk came off of it. And while cleaning it, I discovered that both the engine mounts, although they're not completely broken, the rubber is separating here from the plate. So these need to be replaced, and then I think we can start putting this thing back together. Okay, this crankshaft is pretty rusty. For the most part, it doesn't matter. The rotor only makes contact right here where the taper is. So I'm just gonna use a piece of Scotch-Brite, just go over that and knock off any high spots. And the bolts that hold the bell housing on actually should be Loctited in. You can kind of see just a trace of it right there. And whoever put this on the Subaru did not do that. So these bolts were actually quite loose. Usually I torque them to about 15 foot-pounds, and I'd say they were probably half that and no Loctite. So, you know, if there's a lock washer, you don't necessarily need the Loctite, but in this case, you should put it on. And the torque on that rotor bolt should be around 23 foot-pounds. I don't have a service manual on this, but I have in the past torqued down on one of these before uninstalling it, and it did not turn at 20 foot-pounds, but it did at 25. This one here was actually tightened way past that. You know, if I had to guess, I'd say around 45, 50. So I don't want to do that again. I think 23 should be fine. Okay, and these bolts I'm also going to torque down to about 15 foot-pounds. You could probably go a little bit higher if you wanted to, but I think 15 will be fine. Okay, so down here we do need a spacer to keep this thing level. And in the past I have used a block of wood, and it works pretty well, but it's a block of wood. So this time I am doing something a little different. I've actually done it once before. I'm not sure which video is going to publish first, but the idea is basically this is threaded in, so this can just be removed. And the thread here is an M8 1.25. So what I'm gonna do is use this coupler. It's just threaded all the way through, and it's about 1 inch thick. And that'll give me what I need. You know, this here will get attached like that. And I have an automotive stud that'll thread into here and go up into there, locking everything in place. This frame isn't quite a match. The holes for the stator don't line up. The original stator that was on here bolted on here and here. This one looks like it lines up with these holes, but we need to drill a new hole about 1/2 inch that way. This foot was pretty mangled that came on this machine, so I did stick it in the vise and just straighten it out the best I could, and I think that'll do okay. So I'm going to bolt it on and see how it does. So before going any further, I'm going to get the rope out of the cylinder and pull the engine over. Make sure there's no scraping sounds down in the stator. Sounds good. There's not much left to do down here. I'm just going to connect this ground wire, install the brushes, get the end cover on, and then we'll install the outlets. Okay, we've got a new governor spring. It's from Stens. That's the part number if you're interested. Also, that is the Subaru number. So this clone here, I mean, it runs the engine and it actually sounds halfway decent on the video, but in person I can tell it is running it rich. The engine isn't running quite right, and the exhaust, the smell is quite rich. So, I don't feel comfortable using this carb. So I went out and bought not quite an OEM, but pretty close, meaning it runs it well. This is a Stens carb. It's $90. It's a bit more than the clone, but it'll run the engine much better. So I'm gonna get this one off, get the Stens on, and throw the airbox on, and we'll bring it outside for a test. I am still missing a few things here. I need the air filter, which is on order, the clip for the box, which isn't that important, as well as the gasket here that goes between the carb and the airbox. So there's really not much point in putting the airbox on at this point. So I'm just gonna torque it down like this. We'll test with it while waiting for the rest of those parts to come in. Gonna start it up, bring the engine speed up to 61.5 hertz, and then load it up. I wanna make sure that A, the new spring can get the engine up to speed, and then of course, can it handle the 3,000 watts without losing too much speed. Very nice. Started right up, and the carb doing a great job. It's running the engine very well, and the governor spring, it was able to get the engine up to speed. I think I set it to about 61.5, actually no, closer to 61 hertz under no load, and under 3,000 watts it held at 59.7. So we've got a strong engine and everything's doing what it should, which is good, because later today they're calling for 40 mile per hour constant winds with 70 mile per hour gusts. So I want to finish this thing up. Most likely it'll be sold by tomorrow. Okay, so the new filter did arrive, so we're just about ready to finish this thing up. I think the big holdout here is the gasket that goes between the carb and the airbox. So I did find them, they're available, but they're $15 each. And yeah, I'm not paying $15 for a gasket, so I'm gonna make one. I've got some gasket paper here. If you don't have that, you can use like a cereal box. That also works, but gasket paper will last longer. And the idea is you put it on the thing that you want to make a gasket for. And in this case, this is the clone carb, so at least it has some use, but it has exactly the shape I need. So you put the paper on, get a crayon, and just like you did in elementary school, you just kind of rub the crayon on it, and eventually it transfers the shape to the paper. And once you finish that, you cut it out, then you transfer that over to the gasket material, and then you have a gasket. Something like that. Okay, let's see how this fits. Not too bad. It'll work. Okay, that's good. This comes out at a funny angle. It's actually going the wrong way. It has to turn 180 degrees before it drops down. The big thing here to keep in mind is just make sure that line is clear of the governor rod, or else the throttle could get hung up. The weather's not working in my favor here. Anyway, want to start it one more time, and I just realized I never plugged in the oil sensor. So I'm going to plug that in now. We'll just run it, no load, make sure that the sensor is in fact working. Well, I've got to say, I did not think this was going to fully come back. You know, I expected at least a good power head out of it and was surprised once the engine was running, we had no power. So luckily, the governor was not broken. It just needed a spring and an adjustment. You know, the gen head also not broken. It had a bad bridge rectifier. And of course, you know, the frame that it came on was a mess. The whole thing was mounted crooked. Tank was full of water, and the clone carb wasn't really doing what it should, and no air filter. So this thing had a lot of strikes against it. Thankfully, it all came back, even the oil sensor, and this thing's 100% again. So I hope this video helps someone. Thanks for watching.